What if Earth's frozen giants are disappearing faster than scientists ever predicted possible today now? Every year, global warming silently attacks polar ice caps with devastating and accelerating consequences worldwide. Scientists warn that melting ice sheets are reshaping oceans' weather patterns and coastal survival systems. The Arctic is warming nearly 4 times faster than the rest of the planet today. This rapid ice loss is triggering rising sea levels, threatening millions of people globally now. Polar bears, seals, and entire ecosystems are struggling to survive shrinking icy habitats every day. Glaciers that have existed for thousands of years are now retreating at alarming speeds rapidly. This transformation of Earth's frozen regions is a clear signal of climate instability worldwide today. Scientists study ice cores to understand past climates and predict future environmental changes accurately now. Satellite images reveal shocking shrinkage of polar ice caps over recent decades at unprecedented rates today. The consequences of melting ice extend far beyond polar regions and into human civilization systems worldwide. Warmer oceans absorb more heat, intensifying global weather extremes like storms and heat waves rapidly increasing. Melting ice reduces Earth's ability to reflect sunlight, worsening overall planetary warming feedback loops intensify. Coastal cities face flooding risks as sea levels continue to rise steadily around the world. Permafrost thaw releases methane gas, accelerating climate change even further than expected, scientists warn urgently. Entire Arctic landscapes are transforming from white ice fields into dark open waters at alarming pace. Wildlife migration patterns are changing rapidly due to disappearing sea ice habitats across polar regions. Scientists emphasize urgent global cooperation to slow down irreversible ice cap loss before it's too late. Rising temperatures are not just numbers, but real threats to Earth's stability and future survival. Polar ice melt also disrupts ocean currents, affecting weather patterns worldwide, significantly in complex ways. Greenland ice sheet alone holds enough water to raise sea levels dramatically if fully melted. Antarctica's massive ice reserves are increasingly vulnerable to warming ocean temperatures driven by climate change. Scientists use ice drilling data to reconstruct Earth's ancient climate history patterns with remarkable precision. Global warming is accelerating faster than many climate models had originally predicted in recent decades. Loss of reflective ice surfaces increases heat absorption across Earth's entire system dangerously over time. Arctic sea ice extent continues breaking record lows almost every single summer in modern history. Melting glaciers also impact freshwater supplies for millions of people downstream reliant on them globally. Climate scientists are sounding alarms about tipping points in polar ice systems approaching faster now. Even small increases in temperature can trigger massive ice sheet instability, with cascading effects globally. Rising sea levels may displace entire populations from coastal regions worldwide in coming decades soon. Melting polar ice also contributes to shifts in global ocean salinity levels affecting marine life. Scientists emphasize that Arctic warming affects weather far beyond polar boundaries across continents globally today. Melting ice caps also influence jet stream behavior and atmospheric circulation patterns in significant ways. Polar ecosystems are under extreme pressure as habitats continue to disappear at rapid speed now. Global climate feedback loops are making ice melt accelerate even faster than ever before. Greenhouse gases trapped in atmosphere are primary drivers of polar warming, scientifically proven facts today. Sea ice decline reduces habitats for seals, walruses, and polar bears, endangering their survival significantly. Arctic amplification effect explains why polar regions warm faster globally than any other part of Earth. Glacial retreat is now visible even in satellite comparisons over short periods of just decades. Scientists warn that ice loss could reach irreversible thresholds in coming years without urgent action. Ocean levels are rising due to both ice melt and thermal expansion driven by warming. Permafrost regions store massive carbon deposits now being released into atmosphere due to thawing processes. Antarctic ice shelves are breaking apart faster than previously observed rates in recent studies today. Melting ice reduces Earth's long-term capacity to regulate global temperatures naturally over time without disruption. Scientists use climate models to simulate future ice cap melting scenarios under various conditions today. Arctic Ocean becomes increasingly navigable as ice continues to vanish rapidly during summer months now. The story of melting ice caps continues with deeper impacts unfolding across Earth's fragile climate system today. Scientists explain that polar ice loss is not just regional, but a global, interconnected crisis accelerating rapidly. Every ton of greenhouse gas emissions adds invisible pressure on already weakening polar ice structures worldwide. The Arctic Ocean is transforming from a frozen shield into open water during longer summer periods. This transformation alters how sunlight interacts with Earth's surface, increasing overall heat absorption significantly over time. Ice reflects sunlight naturally, but when it disappears, darker ocean waters absorb more solar energy instead. This process creates a feedback loop where warming leads to more melting and even faster warming cycles. Greenland's ice sheet is one of the most critical indicators of future sea level rise globally. If Greenland melts significantly, coastal cities worldwide could face catastrophic flooding and permanent displacement risks ahead. Scientists use advanced satellites to measure subtle changes in ice thickness and movement across polar regions. These measurements show consistent thinning trends that confirm accelerating ice loss year after year globally now. Antarctic ice shelves act as natural barriers, slowing inland ice from flowing directly into the ocean. When these ice shelves collapse, inland glaciers accelerate dramatically toward the sea, increasing ocean levels faster. Ocean warming is a major driver of ice shelf destabilization beneath Antarctica's massive floating ice structures today. Warmer water melts ice from below, weakening structural integrity in ways not visible from the surface. This hidden melting process makes ice loss more dangerous and harder to predict accurately in climate models. Arctic communities are already experiencing dramatic environmental changes affecting hunting, fishing, and traditional ways of life. Indigenous populations rely heavily on stable ice conditions for transportation and survival across harsh northern landscapes. As ice becomes unstable, travel routes once used for generations are now becoming unsafe or disappearing entirely. Wildlife species dependent on sea ice face shrinking habitats, forcing them into competition for limited resources. Walruses are increasingly forced onto land due to lack of stable ice platforms in Arctic regions. This overcrowding leads to higher mortality rates and ecosystem disruption across fragile polar food chains globally. Scientists emphasize that ice loss is not linear, but can suddenly accelerate after crossing critical thresholds. These tipping points represent irreversible changes that cannot easily be reversed even if temperatures stabilize later. Methane trapped in permafrost adds another layer of danger as it escapes into the atmosphere rapidly. Methane is far more potent than carbon dioxide in trapping heat, making climate change worse quickly. Arctic permafrost thaw also damages infrastructure, including roads, pipelines, and buildings in northern communities today increasingly. Engineers struggle to maintain stability in regions where ground conditions are literally melting beneath their feet. Climate models show that Arctic warming influences weather patterns far beyond polar regions, including tropical storms. Disrupted jet streams caused by polar temperature differences lead to extreme weather events in mid-latitudes globally. Heat waves, droughts, and flooding events are becoming more frequent, partly due to polar ice imbalance changes. Scientists stress that ice caps act as Earth's cooling system, regulating temperature balance across the planet. Losing this system is like removing a natural thermostat that stabilizes global climate conditions over time. Ocean currents, such as the Atlantic circulation, are influenced by freshwater input from melting ice sheets. Changes in these currents can alter weather patterns in Europe, North America, and beyond significantly over decades. Sea level rise is not uniform and varies depending on gravitational and oceanic factors globally differently. Some regions experience faster coastal flooding due to complex redistribution of water mass across oceans worldwide. Small island nations face existential threats, as even minor sea level increases can submerge entire territories. Scientists warn that adaptation alone may not be enough for many vulnerable coastal populations globally today. Ice core records reveal that current carbon dioxide levels are higher than at any point historically. This unprecedented concentration of greenhouse gases explains the rapid pace of modern polar ice melting today. The Arctic is sometimes called Earth's early warning system because it reacts fastest to global warming changes. Observing Arctic ice loss helps scientists predict future global climate shifts with greater accuracy and urgency now. The accelerating loss of polar ice is now reshaping Earth's climate system in unexpected, dangerous ways today. Scientists emphasize that Arctic and Antarctic changes are interconnected with global weather stability across continents worldwide. As ice disappears, darker ocean surfaces absorb more heat and intensify global temperature rise even further. This creates a dangerous amplification effect, where warming accelerates melting and melting accelerates warming continuously now. The Arctic region is experiencing record-breaking temperature spikes far above historical averages recorded in past decades. These extreme changes are altering seasonal cycles that once followed predictable patterns for thousands of years. Sea ice once acted as a protective barrier separating cold polar waters from warmer global oceans. Without that barrier, ocean systems mix more freely, increasing instability in temperature distribution across hemispheres globally. Scientists use climate satellites to track ice movement, thickness, and seasonal fluctuations in real time globally. These observations confirm that polar ice loss is not temporary, but part of long-term structural decline. Greenland's glaciers are now moving faster toward the ocean due to reduced friction from melting bases. This increased glacier flow contributes directly to measurable sea level rise, affecting coastal regions worldwide today. Antarctica's west ice sheet is considered one of the most vulnerable ice masses on the planet. If it collapses significantly, global sea levels could rise by several meters over coming centuries. Even partial melting of Antarctic ice would reshape coastlines and displace millions of people globally. Ocean temperatures are rising steadily as heat trapped by greenhouse gases continues accumulating in deep waters. Warmer oceans not only melt ice, but also disrupt marine ecosystems from plankton to large predators. Fish migration patterns are shifting northward as species search for cooler waters to survive changes. This disrupts global fisheries, impacting food security for millions of people dependent on ocean resources. Arctic amplification explains why polar regions are warming faster than any other area on Earth today. This phenomenon is driven by feedback loops involving ice loss, atmospheric changes, and ocean heat absorption. Permafrost thaw is releasing ancient organic material stored for thousands of years beneath frozen ground layers. When decomposed, this material releases carbon dioxide and methane into the atmosphere, intensifying warming further. Scientists warn this could trigger a self-reinforcing cycle of climate change difficult to stop later. Infrastructure in northern regions is collapsing as frozen ground loses stability due to rising temperatures today. Roads, pipelines, and buildings built on permafrost are becoming increasingly expensive to maintain or repair globally. Indigenous Arctic communities are witnessing dramatic environmental shifts affecting traditional hunting routes and seasonal patterns. Ice-dependent species such as polar bears are forced to travel longer distances to find food. This increases energy consumption and reduces survival rates among already vulnerable wildlife populations in the Arctic. Melting sea ice also reduces habitat for seals, which are essential prey in polar food chains. Scientists observe that younger, thinner ice is replacing older, thick ice across most Arctic regions today. This younger ice is more fragile and melts faster under seasonal warming conditions each year increasingly. Antarctic ice shelves are breaking apart due to ocean water seeping beneath and weakening structural support. When ice shelves collapse, inland glaciers lose resistance and accelerate their flow into surrounding oceans rapidly. This process is one of the key contributors to rising global sea levels observed today. Satellite imaging shows dramatic reduction in multi-year ice, which used to survive multiple Arctic summers consistently. Now, most Arctic ice forms and melts within a single year, indicating system instability increasing rapidly. Climate scientists describe this transition as a shift from stable ice cover to seasonal ice cycles. These changes affect not only polar ecosystems, but also atmospheric circulation patterns worldwide significantly over time. The jet stream is becoming weaker and more erratic due to reduced temperature differences between poles. This instability leads to extreme weather events, including prolonged heat waves, storms, and unusual cold spells globally. Regions far from the poles are now experiencing indirect effects of Arctic ice loss increasingly today. Flooding events in coastal cities are becoming more frequent due to rising sea levels worldwide. Small increases in ocean height can amplify storm surges, causing severe damage during extreme weather conditions. Scientists stress that even if emissions stop today, ice loss will continue due to inertia. The continuing collapse of polar ice is creating ripple effects across Earth's entire climate system today. Scientists now see ice caps as crucial indicators of how rapidly global warming is progressing worldwide. Every additional degree of temperature rise increases the speed at which glaciers and sea ice disappear. This accelerating melt is not uniform, but it is happening faster in polar regions than anywhere else. Arctic sea ice now forms later in the year and breaks apart much earlier than before. This shortened freezing period prevents ice from reaching the thickness needed for long-term stability. Thin seasonal ice replaces thick multi-year ice that once dominated Arctic Ocean surfaces for centuries. This shift weakens the entire Arctic ecosystem and reduces habitat stability for countless dependent species. Scientists use long-term satellite records to confirm consistent downward trends in ice coverage globally today. These datasets reveal that recovery during colder years is insufficient to offset long-term melting patterns. Greenland's glaciers are now contributing significantly more freshwater into the oceans than in past decades. This freshwater influx disrupts ocean density and alters deepwater circulation patterns that regulate global climate. Antarctic ice loss is especially concerning because it holds the majority of Earth's frozen freshwater reserves. Even small destabilizations in Antarctic ice sheets can lead to long-term irreversible sea level changes. Ice shelves act like protective walls, slowing glacier movement from land into surrounding ocean waters. When these shelves break apart, inland ice accelerates rapidly toward the sea, increasing melt rates significantly. Warm ocean currents are now reaching farther beneath ice shelves than ever previously recorded in history. This hidden underwater melting is one of the most dangerous drivers of polar ice instability today. Climate scientists warn that once certain ice thresholds are crossed, collapse becomes unavoidable and self-reinforcing. This creates a tipping cascade where multiple ice systems begin failing in sequence across polar regions. Arctic amplification continues to intensify, making polar regions respond more violently to global temperature increases. This amplification is driven by feedback loops involving ice loss, heat absorption, and atmospheric changes combined. Methane release from thawing permafrost adds another layer of warming that accelerates atmospheric temperature rise globally. Methane traps heat far more efficiently than carbon dioxide, making it a critical climate concern today. As permafrost thaws, ancient organic material begins decomposing after being frozen for thousands of years. This decomposition releases greenhouse gases that further increase warming and destabilize ice systems even more. Infrastructure damage in polar regions is becoming more severe as ground stability continues to decline rapidly. Entire communities are forced to adapt as traditional settlement locations become unsafe due to thawing ground. Wildlife species are also losing access to stable hunting grounds as ice conditions become unpredictable yearly. Polar bears are increasingly seen swimming long distances in search of stable ice platforms for survival. This extra energy expenditure reduces reproduction rates and threatens long-term species survival across Arctic ecosystems. Seals, walruses, and other ice-dependent animals are being forced into overcrowded land areas for refuge. These overcrowded conditions increase competition for food and lead to higher mortality rates among populations. Scientists observe that younger ice formations are less resilient and more vulnerable to seasonal temperature changes. This younger ice melts faster, reducing the overall stability of Arctic sea ice systems year after year. Antarctic ice sheets are also experiencing increased surface melting due to warmer atmospheric temperatures above. Meltwater pooling on ice surfaces can accelerate collapse by weakening internal structural integrity over time. Satellite imagery shows dramatic fragmentation of ice shelves that once appeared stable for centuries historically. This fragmentation signals deeper instability within the Antarctic ice system that could accelerate global sea level rise. Ocean warming is not only melting ice, but also altering global marine ecosystems at every depth level. Fish populations are migrating toward colder waters, disrupting fishing industries that rely on stable ecosystems. This shift threatens global food supply chains that depend heavily on predictable marine resource availability worldwide. Rising sea levels are already impacting coastal erosion in many low-lying regions across the globe today. Even minor increases in sea level intensify storm surges and coastal flooding during extreme weather events. Scientists emphasize that the consequences of melting ice caps are now extending far beyond polar regions into everyday global life today. Scientists explain that polar changes are directly influencing weather patterns thousands of miles away from the poles. One of the most visible impacts is the increasing frequency of extreme weather events worldwide recently. Heat waves are becoming longer and more intense as global temperature regulation systems continue to weaken gradually. At the same time, some regions experience unexpected cold spells due to disrupted atmospheric circulation patterns. This instability is closely linked to weakening temperature differences between polar and equatorial regions globally today. The jet stream, which guides weather systems, is becoming slower and more erratic than in previous decades. This causes weather patterns to stall, leading to prolonged droughts, floods, or storms in affected areas. Melting ice caps are also contributing to rising sea levels that threaten coastal cities worldwide increasingly. Cities like New York, Dhaka, and Jakarta face long-term risks from encroaching ocean waters over time. Even small sea level increases can amplify storm surges, causing devastating flooding during hurricanes and cyclones. Scientists warn that millions of people may be displaced from coastal regions in coming decades globally. This creates a new category of climate migration driven by environmental instability rather than economic factors. Island nations are among the most vulnerable, with some facing partial or total submersion risks soon. Entire cultures and communities could be lost if rising seas continue at current accelerating rates globally. Glacial melt also affects freshwater availability for communities relying on seasonal meltwater for drinking supplies. Rivers fed by glaciers may initially flood but later shrink drastically as ice sources disappear completely. This creates long-term water scarcity issues in regions dependent on stable glacial runoff systems worldwide. Agriculture is also affected as changing water supplies disrupt planting cycles and crop production stability. Scientists highlight that food security is indirectly linked to the stability of polar ice systems globally. Ocean ecosystems are experiencing major disruptions as warming waters shift species distributions and breeding patterns. Coral reefs are bleaching more frequently due to rising ocean temperatures driven partly by ice loss. These ecological changes affect biodiversity and threaten entire marine food chains across global oceans today. The loss of sea ice also impacts global carbon cycles by altering ocean atmosphere gas exchanges significantly. Polar regions once acted as carbon sinks, but are now becoming less effective at regulating emissions. This reduces Earth's natural ability to balance greenhouse gases already accumulating in the atmosphere rapidly. Scientists stress that feedback loops from ice loss are making climate stabilization increasingly difficult globally. Each additional year of warming increases the risk of crossing irreversible environmental tipping points permanently. These tipping points could lock Earth into a much warmer state for centuries or longer periods. Permafrost thaw continues to release ancient greenhouse gases that intensify warming across global systems further. Infrastructure damage is increasing in northern regions as unstable ground causes roads and buildings to collapse. Repair costs in Arctic communities are rising significantly due to unpredictable environmental conditions each year. Indigenous communities are adapting to changing ice conditions that affect traditional hunting and travel routes. Loss of sea ice reduces access to marine animals that are essential for cultural survival practices. Wildlife displacement is forcing species into unfamiliar territories, where survival becomes increasingly difficult over time. Polar bears are now traveling longer distances across open water to find stable ice platforms. This increases energy expenditure and reduces reproductive success rates among already stressed populations globally today. Scientists also observe changes in migration patterns of birds and marine animals linked to ice loss. These biological shifts indicate how deeply interconnected polar ice systems are with global ecosystems overall. Antarctic ice melting contributes significantly to global sea level rise, even though it is geographically isolated. Ice shelf collapse events are becoming more frequent as ocean warmth penetrates deeper beneath floating ice structures. This hidden melting process is one of the most concerning drivers of long-term ice instability today. Climate models now incorporate more aggressive ice loss scenarios due to updated observational data globally. These models suggest faster sea level rise projections than earlier scientific estimates had predicted previously. The final reality of melting ice caps is that Earth's climate system is approaching irreversible transformation today. Scientists emphasize that polar ice loss is one of the most urgent warnings humanity has ever received. If current trends continue, future generations may never see stable polar ice as we once knew it. The disappearance of ice is not just environmental, but deeply connected to human survival systems globally. Rising seas will permanently reshape coastlines, forcing massive adaptation in infrastructure and human settlements worldwide. Entire coastal economies could be disrupted as ports, cities, and farmland become increasingly vulnerable to flooding. Climate migration may become one of the largest movements of people in human history over time. This shift will challenge global stability, resource distribution, and political systems across nations in coming decades. Scientists warn that ice-related tipping points, once crossed, may not be reversible on human timescales. This means some changes already set in motion could continue, even if emissions are drastically reduced now. The Arctic is expected to experience ice-free summers in the near future under high warming scenarios. Such a condition would fundamentally alter global weather systems and ocean energy balance permanently worldwide. Antarctica's stability is equally critical, as its ice sheets hold the majority of Earth's frozen freshwater. Continued warming could unlock vast amounts of ice, accelerating sea level rise beyond current projections significantly. Scientists stress that every fraction of a degree of warming avoided can reduce future ice loss impacts. This makes immediate climate action one of the most powerful tools humanity still has available today. Renewable energy transition is central to slowing emissions that drive polar ice destruction across the planet. Technological innovation alone is not enough without global cooperation and strong environmental policy enforcement worldwide. The fate of ice caps is directly tied to human decisions made in this critical century. Arctic and Antarctic regions are no longer remote zones, but central indicators of Earth's health system. Their rapid transformation reflects the scale and speed of human influence on planetary climate processes today. Scientists continue to monitor ice loss using satellites, drones, and advanced climate modeling systems globally. These tools provide undeniable evidence that polar ice is shrinking faster than historical norms recorded. Ice cores continue to reveal Earth's climatic past, showing how unusual current warming truly is today. The contrast between ancient stable ice layers and modern rapid melting is scientifically striking and alarming. Ecosystems dependent on ice are collapsing faster than they can naturally adapt to environmental change globally. This loss of biodiversity has long-term consequences for planetary ecological balance and resilient systems overall. Ocean circulation changes driven by ice melt may reshape rainfall patterns across entire continents in future. This includes impacts on agriculture, water availability, and food security for billions of people worldwide. Scientists emphasize that climate systems are interconnected, meaning polar changes affect every region on Earth. The melting ice crisis is therefore not isolated, but a global challenge requiring collective responsibility. Each year of delay increases risks of reaching climate thresholds that cannot be reversed later. The evidence clearly shows that polar ice caps are vital regulators of Earth's climate stability. Losing them would mean entering a fundamentally different planetary state with higher temperatures globally sustained. This future scenario includes higher seas, stronger storms, and more extreme and unpredictable weather patterns. The urgency of action is reinforced by every new scientific observation of accelerating ice loss. Humanity still has the ability to slow this process through coordinated global environmental efforts today. However, the window for preventing worst-case outcomes is narrowing rapidly according to climate scientists worldwide. The melting ice caps are both a warning and a call for immediate transformation of global systems. Understanding their importance is essential for shaping policies that protect future generations from climate disruption. The choices made today will determine whether polar ice stabilizes or continues irreversible decline globally. Scientists agree that protecting ice caps is directly linked to protecting human civilization's long-term future. Every degree of warming avoided preserves more of Earth's frozen systems and climate balance stability. The story of melting ice caps ultimately reflects the broader story of human impact on Earth. It is a reminder that planetary systems are fragile and deeply interconnected across all regions. The Arctic and Antarctic stand as silent witnesses to rapid environmental change.